All right, everyone. Thank you for joining us today. Welcome to the Wet Center webinar series. Today, we'll be discussing with Charles Hillyer, Director of CIT, the Center for Irrigation Technology. What is CIT and how can CIT help you if you're a startup founder or just generally in the industry with whatever you're working on? So just quick background on the Wet Center. For those of you who don't know what the Wet Center is and are joining us for the first time, the Wet Center is an incubator / accelerator at Fresno State. We focus on water, energy, and agricultural technologies. We have office space, we have acceleration programs, business development programs, and other resources available for startup founders to grow their business within the Central Valley. So if you want to learn more, please feel free to go to wetcenter.org to learn more about what we offer and what we could perhaps do for you. So today we'll be focusing on the Center for Irrigation component, which is the sister organization or parent organization of the Wet Center. And Charles, I'm going to do a quick background on you, but thank you for joining us today.
Thank you for having me.
So a quick background on Charles. Charles has an extensive background in irrigation and agriculture, having served as a trusted subject matter expert and working at several universities and businesses. Charles has a Bachelor's of Science in Agricultural Engineering from Mississippi State University and a PhD in Bioresource Engineering from Oregon State University. Charles has served in various research and faculty capacities for institutions such as Oregon State and Texas A&M AgriLife. Charles was also the CTO of Irrigation for the Future. Most recently, Charles is the director of the Center for Irrigation Technology, CIT, where he advances the organization into new territory. Charles, I know we've got a lot to cover today, so would you mind just kind of giving us an overview, just a background of CIT and what you guys do, and then we'll go into the details as we go through the webinar today.
Sure. So CIT is part of Fresno State. We're one of 3 institutes on campus that are part of the California Agricultural Technology Institute. Our mission is to basically further irrigation technology in California and nationwide and even worldwide. We do that through a combination of third-party testing of irrigation hardware, applied research and education, and more recently through cooperation with the Wet Center for Entrepreneurship. So our focus is basically on looking at the technology, measuring it, understanding it, and finding ways to improve it, right? And then disseminating that information both to growers and the industry. So that's our general mission.
Excellent, thank you. I know we have a short video we wanted to share. I think it'd be a great place to start, and then of course we can go further from there.
Okay, let's get my screen shared here. So that's a photo of the Wet Center, which is where the business incubator, and then behind that is our hydraulics laboratory, and I'll talk a little bit about that in a minute. But before that, here's a video.
Fresno State's Center for Irrigation Technology is recognized worldwide for its innovative testing, applied research, education, and entrepreneurship programs. The center actively promotes more sustainable technologies related to water, energy, and agricultural management, while also considering environmental and urban factors. The center's reputation for developing new industry standards is tied to its laboratory and field testing. Independent, third-party data is instrumental in documenting and improving new product performance. CIT was formally created in April of 1980, yet traces its roots back over 80 years to the pioneering work of Dr. Winston Strong. A faculty member for 34 years in the Plant Science and Mechanized Agriculture Department, Dr. Strong established the Sprinkler Test Station in 1953 at the site of the Future Labs. Operations have grown considerably, and today's 18,000 square feet of lab space now tests a complete range of irrigation equipment. Its ISO 17025 certification ensures its work quality and attracts manufacturers, growers, and government organizations from around the globe. Field testing is enhanced by the surrounding 1,000-acre University Agricultural Laboratory and its wide variety of crops. Flood, drip, and overhead irrigation systems can access groundwater from wells and surface water from canals. The staff also work closely with the Water, Energy, and Technology Center to provide entrepreneurs and innovators with technical assistance, product research, and development. CIT takes pride in its educational programs that connect the community, industry, and government. Its mobile education centers allow programs to go straight to the audience and travel throughout the state. Free data management tools are also created by researchers and easy to access online. Staff and faculty share expertise with students in applied research projects and provide valuable hands-on experience. California's San Joaquin Valley is the nation's most productive agricultural area, but its water management policies face a complex future. CIT supports a long-term focus that factors in shared water availability, need, and delivery. With its commitment to new technology and interconnectivity, the Center for Irrigation Technology is well-positioned to support new solutions that have long-term benefits locally and worldwide.
So that's a nice overview of CIT. I'll go into a little bit more detail about our facilities, but our focus basically is three areas. One is the hydraulics testing laboratory, and we'll see a couple photos of that. The second is the research or the applied research activity that we have. And then there's the technology incubator and accelerator program. If you guys are familiar with the Wet Center, you know all about that. Ben can tell you everything you want to know about it. So I'm not going to talk too much about that, but I am going to talk about our physical facilities. So CIT occupies several buildings on the corner of Barstow and Chestnut, right on the Fresno State campus. The lab itself has been around, as mentioned in the video, for about 40 years. And we do a wide range of physical testing of irrigation technology. We also work with companies and entrepreneurs and really anyone who's interested to develop testing protocols. These protocols can help define a way of measuring some particular aspect of the device, and it creates an objective basis for quantifying their performance. That's always been a big part of our testing, because a large part of our testing is what we call special tests. These are the really exciting and interesting things that come into CIT, where there's a new technology and the manufacturer wants to measure or test some particular aspect of it in a way that's objective and unbiased. So we will actually work with them to develop a test protocol. That's basically a very specific set of steps on how we would actually measure that. And those steps are repeatable at other locations. So it's not just us doing a special measurement, it's a description of how to do the measurement so that other labs could repeat that measurement and hopefully achieve the same results. Something else that CIT has been known for over the years is failure analysis. This is particularly useful for growers when they've got a piece of equipment and they're not sure that it's functioning the way they thought it should. We occasionally will get the growers to bring those devices to us, and we will run it through either a standard set of tests that are industry defined, or in some cases a special test, to figure out if the device is actually functioning the way they thought it would. That was something one of our former directors, Ed Norum, has had a lot of experience with. He calls it the forensic analysis of irrigation systems. And it ends up being a really interesting detective activity where we try to figure out what's going on with this device and why isn't it working the way we thought it would. So our main hydraulics lab, we call it the CIT hydraulics lab, the picture of the very modern looking building that you saw in the beginning. This is the back end of that. It's quite large, 13,000 square feet. We have an array of pumps and also a large set of motors, so we can do a wide array of pump testing. We can test up to 6,000 GPM and I think up to 200 PSI. We have a large test bit, so we are recirculating the water as we test these devices. In addition to the hydraulics lab, we also have our sprinkler testing laboratory. This was actually the first purpose-built building for CIT. It's basically a large empty building, but you need a building like that to test sprinklers because it's important that you test them in a zero wind condition. So when you're testing and measuring agricultural sprinklers, you want to measure them indoors. That's a little bit counterintuitive when you think, well, these sprinklers are going to be used outside. But when you're trying to very precisely measure the performance, particularly the distribution of a sprinkler, you need to do it in a no wind condition. And so that building was purpose-built for testing irrigation sprinklers. We also have a very sophisticated piece of software that was developed at CIT quite a few years ago for collecting, computing, and quantifying the statistical performance of these devices. And we have an array of standard tests that we do. It would take a while to go into details of all of them. But this is just to give you a sense of the range of testing that we do. These are fixed price tests, so we do quite a few of these for the industry. Turnaround time can be anywhere from a few days to a couple months, depending on the backlog in the lab. But these are basically tests that are defined by an established or recognized standard, either through industry groups or sometimes through local governments. There are a few tests that we actually develop the process ourselves, and aspects of those tests are accepted by other members of the industry. So in addition to the testing laboratory, we also have a very large applied research program. Several years ago, the Fresno State Farm allocated a specific area of the farm just for applied research. It's 7 acres, so it's not huge, but every year we pack a lot of research into those 7 acres. This is an area where we can do basically anything we want. There's no expectations that we will generate revenue from whatever is grown on those lands. So we can do test pretty much anything that requires in-field testing in an agricultural context. In addition to the testing that we do through the lab, we also provide what's called post-award administration for the plant science and industrial technology departments. So whenever the faculty have a grant that requires in-field testing or in-field research, we can support that activity with the acreage as well as our expertise. One thing I want to draw your attention to is this white circle right here. Part of this 7 acres is specifically dedicated to turf research. While we have a very obvious focus on agricultural irrigation, an important part of the testing laboratory and our applied research has always been the landscape irrigation. So we have an area that's specifically allocated with permanent turf plots. Also, you can just barely see it, but one of the plant science faculty, John Bushoven, has a research project going on here that is part of the National Turf Grass Evaluation Program, which is the only one in California. So I mentioned that we have our 7 acres, which is just right there, but we are also part of the Fresno State Farm. This is a 1,000-acre farm. It's fully diversified and represents basically all of the things, or almost all of the things, that are happening in the San Joaquin Valley. So they've got drip, micro sprinkler, there's a pivot on campus, they still do some surface irrigation, there's several animal units, there's a wide variety of crops. This farm is really special in that their mission includes both teaching and research, but they also have to produce revenue from the farm to support its operations. That keeps the farm grounded in actual real agricultural practices. So the farm has all the same kind of constraints that a grower would have, which means that when we try to do research on the farm, we have to make that research, whether it's a new technology or a new practice, we have to make that fit in with normal agricultural practices. This, from my perspective, is essential in whenever you're trying to validate or test a new practice or a new technology. You've got to make sure it's tested in realistic, normal agricultural context. And the Fresno State Farm gives us that kind of a context. So that was a bit of a whirlwind tour of CIT, and I'm going to stop sharing so that Ben can take over again. Ben?
Yeah. Sorry, I was switching screens here a little bit. Charles, thanks for that. That video is fantastic, by the way. Really gives a good overview, and it's nice to see all the CIT staff and everyone there. And speaking of the CIT staff, I wanted to just dive in a little bit further. I know that there's quite the range of expertise and backgrounds. We don't, I'll leave it up to you if you want to go into specific names, but overall, just what are the areas of expertise that CIT has on staff that can we can see as having credibility on certain subject matters?
Sure. So CIT has a couple of staff researchers. First is Keamine Bang. He actually runs the hydraulics testing laboratory. So he's got a really extensive experience in the hydraulic components of that are basically all of the things that get wet in an irrigation system. He has experience in testing those devices and measuring their performance. Keamine also has an active research program. He's got one study that's going on our research plots looking at nitrate movement in soil. We have Dilruba Yasmin. She's been with us for quite a few years. She tests an active research program that studies a variety of ag engineering topics. One thing to highlight is her work with ground penetrating radar. She's got a research program that's developing a method to map out where the roots are underground in an orchard using this ground penetrating radar technology. That's a really exciting idea because to measure where the roots are in an almond orchard, you have to dig them up, right? It means you can only measure it once, right? You can't put it back. But with this technology, it's possible to repeatedly measure where the roots are in the soil without disturbing the soil. So that's an active program that is, for me, really exciting. Sarge Green, who has been with us for a very long time and is also associated with the California Water Institute. He looks at all aspects of water policy. And so he brings a real tremendous wealth of experience looking at the interactions between irrigation districts and agricultural practices and state and local policy. Sean Ashkin is an agricultural engineer who's been with us for a really long time. He also studies basically all aspects of agricultural engineering relating to irrigation. Typically, when we're doing a large-scale special test, Sean will be the research leader, in effect. In addition to those research staff, we also work very closely with several plant science faculty. In particular, I want to mention Florence Kessel and Dave Guruhu. They do a lot of research here at Fresno State with a wide range of topics. Florence has been doing studies on salinity, different methods of irrigation. She did a really interesting study recently on produced water from oil wells. Dave Guruhu has done a tremendous amount of work with a topic called airjection, which is a way of injecting gases into the irrigation stream that's been shown to improve yields. And then there are several other faculty that we work with on a regular basis. Cordy Quale from the College of Engineering, Faisal Pasha, who's doing a lot of really fascinating work in the Internet of Things and sort of high-level systems integration. And then we also have collaborations with other institutions. CIT is part of the Irrigation Innovation Consortium, which is a 5-university consortium that focuses on irrigation technologies and developing those new technologies that benefit the whole industry. So we have a pretty large network, both of our full-time staff, the larger network of the campus faculty, and then other universities outside of our institution.
Excellent. So obviously there's a lot of resources here, for lack of better terms, a lot of things are going on. For the founders that we work with that maybe they're familiar with the Wet Center, let's just go in with that assumption. They know some of our programs and they've heard about CIT. What are the benefits of working with CIT that you found that founders are coming across as they work with you, they engage in projects, and we can go into examples later, but I'd love to hear just kind of like how CIT has benefited or could benefit a startup in this space.
So the fundamental benefit of working with CIT or any institution like CIT is third-party validation, right? And this applies both to founders, to established industry, really anybody who wants to have a measurement of their product or process or device that has credibility in the measurement, right? Third-party validation basically means that whatever data is coming out of that test is independent of any conflict of interest, right? So it's basically objective data. For a venture or a startup company, if you've got some new technology and it's something that nobody's ever seen before, and the venture wants to make some claims about it improves yield, or it reduces soil salinity, or it improves infiltration in the soil. Lots of products have made claims like that over the years, and sometimes it's true and sometimes it's not. By working with an institute like CIT, you basically get somebody else to measure and validate that claim. And so when the companies can take that claim to their customers or their investors, there's no conflict of interest. There's no question that it does what they say it does. So the benefit to a venture is basically to give their customers confidence that the device does what they say it does. That's the fundamental benefit, is to give your customers confidence that this will actually work.
In the course of testing, so let me put it this way, is it's applied research. So let's do two stages here. If a founder is still in the process of developing their product, is that the right time to engage CIT, or is it?
Sure. So product development is one of the really exciting things that we do, right? We will work with startup companies who have a good idea. Maybe they've done some laboratory scale testing, or they've tested it in their garage or something like that, and they want to try it out in a real agricultural production context, right? So we can do that on our 7 acres, and it's sort of, blue sky research. We can do it on the Fresno State Farm. There are more constraints there, but those are the constraints that you want to have when you're doing product development, because you want to make sure it's going to work on any farm. For those types of tests, it's a little bit more involved, and it's not third party because we're actually establishing a partnership. But we will work out a scope of work. We'll set up a budget, and then we'll do some back and forth with the founder to try one thing and then try another thing and go back and forth. For pre-COVID and post-COVID, they'd be able to come out here and work on their devices on site. Basically, it gives a founder more resources than they would normally have in their garage or their laboratory. But it also gives them some expertise of people who've been doing this for a really long time.
Excellent. And then just to be clear, if they come to you at that stage, can they continue with you on the third-party testing, or?
Yes, certainly. So the fundamental difference between product development and third-party testing is the third-party testing is hands-off. The process for a third-party validation is we sit down with the founder and work out a scope of work and a test protocol, right? And that test protocol is going to say very specifically what we will measure, how we will measure it, and how we're going to report it. Once we agree on that and we establish a budget, then it's hands-off. We do all the measurements, we collect all the data, we produce a report, and we deliver it to the client. So the third-party validation has that sort of wall between us and the client that maintains our conflict of interest-free environment. And sometimes the measurements work out, sometimes they don't. And we deal with that basically by saying that when we give the report to the client, it's up to them how they're going to distribute that report. The only string that's attached is that if they decide to distribute the report, it has to be distributed unmodified. Right? That's the only requirement that we put on it. So if they do a third-party validation and it's measuring some aspect of the performance and the performance didn't actually work out the way they wanted, we're not going to go shout that from the mountaintops. That's up to them.
Makes sense. And kind of speaking on testing overall, Charles, I know you have a lot of experience with seeing different products come through the industry, some successful, some not. For the founders that have a list of priorities of what they just limited budget, limited resources, and prioritization, how would you walk them through the thought process on deciding, whether testing is worthwhile, whether the product research is worthwhile, partnering with CIT? How can they think that through as far as, and I know it's case by case dependent, but how would you recommend that they think that through as far as how they should be prioritizing that as far as their budget may go?
For the product development, so I'm going to answer that question twice. One's for product development, and one's for third-party testing. On the product development side, the founders need to ask themselves, do we need to do this in an agricultural setting with experts from the industry or from academia? Or can we continue doing this in our garage or our laboratory or our own facilities, right? There are some aspects of testing you don't need to do that in a real agricultural production context, you know, like software testing, things like that. If you really want to have the rigor and the practical constraints of testing in an agricultural context or developing in an agricultural context, then yeah, this is the right place. But if you're still tinkering with things, maybe this isn't the right place. Doing product development here, it's not inexpensive. You know, our overhead costs are very low compared to other universities, but it's not cheap by any stretch of the imagination. You know,
Sure.
we have resources, but you know, we're essentially grant and contract driven. So we have to be able to derive enough funding from these partnerships. On the third-party testing, basically you need to ask yourself this question: do you need to give your customers confidence that your product works the way you say it does? There are some products where its utility is going to be immediately obvious just by looking at it, right? A mechanical device or a software platform, just by looking at what it does, just you can decide right away, oh yeah, that's going to work for me, or it's not, right? There are other devices where it's impossible to do that just by visual inspection or intuition, right? So a soil additive, you know, an amendment or an adjuvant, a fertilizer supplement or things like that. You really need field testing and validation to show people that it works the way you say it does. So scenarios like that, that's where third-party testing can be really beneficial. There have been devices out on the market which had questionable science backing them up. The marketing and sales were really, really good and really convincing, but without that science backing it up, without the science coming from someone who has no conflict of interest, it's difficult to decide, unless you're a scientist yourself, if that device is really going to work for you. The only way you can find out is to buy it and try it. So third-party validation is a way for the ventures to show to investors and to clients that, look, it's not us saying this thing works. Here's CIT, they tested it, and this is what they found in their test, right? Because in our test reports, we generally don't have conclusions. We say what we were going to do, we say what we did, we show the measurement, and that's it. There's no sort of it's good or it's not kind of statements. We don't endorse products. We just say what we did and we report it. The value to the customers is in the test protocol, where we're actually measuring very precisely and very specifically the aspect of that device or product or procedure that is of value to the customer.
One area I want to discuss briefly here that at least I've seen is there's some products that have the appearance of immediate utility, but until they have some level of third-party validation, so let's say longevity or other factors that they may not be aware of, to where their assumptions in the agricultural space are maybe they have a lack of experience and they're assuming how things work and they're missing some critical points that would maybe change the business model, the product design. What are your comments on that, Charles, to where for the companies that are like, hey, you can see automatically if it works or not, for products of that nature, are there situations to where third-party validation over a period of time will eliminate some of the errors and problems and give validation still?
Yeah, on the practical side, field testing in an actual production context is where you're going to experience all those practical problems that you would have never thought of before. I mean, every time we do a new client who's testing something, I'll learn something about practical limitations that which just have never occurred to me. It
Sure.
wouldn't occur to anyone. That's the value of doing this in a real production context. On the third-party validation for long-term testing, that's a bit more challenging. Now, we can do that here. We can install a device in one of the orchards and make sure it's running, but that takes time. I mean, it's a long-term test. There's unfortunately no way to get around that. I mean, there are some specific testing protocols that are designed to simulate accelerated aging, but the long-term effects on a olive orchard from a particular foliar application, I mean, we could do that here, but it would take many, many years.
Excellent. So for the founders here that maybe have a few customers so far, the science is, let's say there's a intuition behind it, but it does require testing. The founders that have started with their customers and they're taking measurements and results, I know we talk a lot about test protocols and the value that brings. Can you just describe to us some of the differences or some of the values that come from having a quality test protocol versus like, here's some customer reviews pretty much of our product and what it's done for us? And how does that affect the industry and a company's growth rate?
Yeah, so the fundamental difference is basically the difference between anecdotal evidence and statistical evidence, right? When we do test protocols, one of the things we define is going to be how many samples you're going to take, right? The replications. Agriculture and agricultural research, there's always a lot of uncertainty involved. And there are statistical techniques or procedures that you can use to mitigate that uncertainty. So if we were going to test a new sprinkler in the field, some new sprinkler that's got some aspect of how it works, if you just put one sprinkler out there and you got great results, you wouldn't be able to say if those results are because of the sprinkler or because it was a good year or because the crop was particularly good that year, or you just happened to put it in the right place for the right soil for that crop. So you overcome that by replicating. You do many measurements. You do the same thing several times. In addition to that, you also have to separate out sort of the cause and effect, right? So if you say that your product improves yield, well, there's lots of things that can improve yield.
Yes.
Lots of things that can reduce yield. So you have to design a test protocol or an experimental design that isolates the effect of your product from all the other things that can affect yield. Right. So if you say that our product reduces turbulence in drip lines, right, you would have to figure out, okay, well, what else is going to affect turbulence in drip lines? Can we set up situations that are quote unquote normal for agricultural production and measure the turbulence both with and without the product, right? So we'd have replications, we'd have the right context for testing it, we'd have the right drip lines for measuring turbulence, we'd have the right devices for measuring turbulence, and all of that would be specified in the test protocol. That test protocol gives you the scientific rigor that is convincing to investors to show that, yeah, this really does work the way we say it does, and we know why it works. It's that knowledge that gives you the power to say to your clients or your investors, yeah, this is the real deal, and we can prove it.
Charles, wouldn't you say that in your experience, most of the growers see right through the anecdotal information? I mean, they're looking for the hard science, right? In some cases. Yeah,
they are. And they're looking for the hard science, and they're looking for the science to come from a credible source, right? They're growers. Farming is a complicated business. You have to be pretty smart to be successful if you want to be a farmer. But the knowledge, that sort of the depth of knowledge required to measure the performance of a new technology, usually you need somebody with a PhD who understands that aspect of what you're measuring. That's not to say that the farmers can't understand it. Of course, they're perfectly capable of understanding it, but it requires effort and time and education to do that. So they look to the universities for that expertise, and they look to the universities for that third-party conflict of interest-free validation based on our knowledge and expertise. So the growers can look at a new thing and look at an anecdotal evidence. They'll know right away, well, that's an anecdote or it's not, right? But then when Fresno State or UC Davis or Texas A&M or Oregon State shows up with a report that says, we did this with this device and this is what we measured and this is the results, the farmers generally trust that because they know that we're going to tell exactly what we did regardless of the outcome.
Makes sense. So when we talk about credibility, obviously CIT has a long history, just down to not only the staff, but the protocols, the labs. That credibility goes a long ways. Could we speak a little bit to why CIT, and specifically if someone is looking for testing, why they would want to consider CIT perhaps over other facilities or other opportunities?
So there are other labs that do some of the stuff that we do. The ITRC at Cal Poly does a lot of testing. Texas A&M does a lot of testing, and there are other laboratories across the country that will test irrigation or water related products. So we have some competition. Our laboratory is unique in that it is ISO 17025 certified. This is an international standard that defines constraints and performance requirements for an independent testing laboratory. We get audited every year. We just had our annual audit last week, earlier this week. It's a very rigorous standard that defines how you conduct your business in the testing laboratory. It protects intellectual property. It shows that all the people who work there are competent. It's basically our badge that shows we know what we're doing, and we do it correctly every time. In addition to that, Fresno State is in the center of the San Joaquin Valley, the Central Valley. So we're sort of at the heart of where things are really happening in California. So we don't have to travel 300 miles or 500 miles to reach the right agricultural production context if we don't have it on campus. But for the most part, we do have it on campus, right? We're doing field crops, row crops, orchards, vegetables. There's a beef unit, a dairy, a poultry unit, a swine unit. There's a huge amount of vineyards. Fresno State's doing it all. So regardless of what aspect of ag production your product influences, there is probably something happening on campus that's relevant to that product. So those are the two, in my mind, the things that really set CIT apart. One is our commitment to being ISO certified, right, and the constraints that puts on our laboratory. The second is just where we are and who we're associated with. We're associated with the Fresno State Farm. We're part of the Irrigation Innovation Consortium. We're very active with the Irrigation Association. We're very active in ISO and ASABE on standards development. So whenever there's a new standard, we're usually involved in developing or criticizing that standard. And at the same time, we are also doing education. So all the stuff that we're learning about here through our research and activity, we're also trying to share that knowledge with the community.
Excellent. And in addition to all that, I think one thing to add as well is CIT has been here for quite a while. The industry knows the name.
Yeah.
For those that are new to the area or new to the industry, just overall founders, there's something to be said about the Center for Irrigation Technology's name. And a lot of people recognize that, especially if you want to do business in the Central Valley. It's you got to be hard pressed to find another organization that holds as much credibility and respect that this one does, especially when it comes to this subject material.
Yeah, there's one thing I'd add is that drip irrigation really came of age here in the Central Valley. A lot of the major manufacturers are here. There's a long history of manufacturing and developing irrigation devices right here in the Central Valley and even in Fresno in particular. And CIT was there as it happened, and the role that CIT played in that revolution was that when these new devices were coming out, some of them worked really well, some of them worked okay, and CIT was there testing them and establishing, okay, this is the best test to figure out what is the burst pressure of thin wall drip tape, or the best test to measure the distribution of a sprinkler, or the best way to measure the clogging capacity of a drip emitter. So CIT was there while it was happening, and CIT was basically providing the testing and the objective measurements that made drip irrigation trusted. And part of the reason, not the only, but part of the reason why drip is now everywhere in California and in the world.
Excellent. Well, and people remember that. I just want to throw that out there as people know where this came from. I want to hit some of the questions here. One of my next questions, which I think was great, is, are there any funding opportunities to fund new technology testing so that CIT as a third party can conduct the testing without having funding? Here, some of the typing. Basically the question here involves what I would probably define as grant funding or other funding sources. So obviously we know this testing is expensive and in the sense that it's quality, but it's not cheap. So it's good value, but we understand that it does require some funds to be able to get this moving forward. For some of the funding sources out there, Charles, I know that CIT has done great work helping founders with their testing through the course of a grant. How does that all work? What does that look like? Does CIT apply for grant funding? Do founders write grants and write you guys in? How does that work?
Yeah, so there's a couple different avenues for that to happen. One is CIT can apply for grants. We're part of Fresno State, so we can go after state and federal and local grants, and we can bring the founder in as a subcontractor. Typically, these grant programs will have very specific research sort of goals or objectives. And so in that context, we have to find a way to bring the new technology in as a way to answer a specific research question, right? So it's not really product testing per se. It's answering an applied research question that involves using that technology. And so we'll end up generating data for that research goal that's also relevant to the founder, right? So if it's a new pump control algorithm, we could be testing that here as a part of a research project for evaluating different pump control algorithms, right? So in that scenario, the new technology is part of the research program, but it's the research program that's sort of steering the ship. Another role is for CIT to be a subcontractor, right? So there are some grant programs, most notably the SBIR program, which vendors can apply to get funding. And some of those SBIR grants require that a portion of the grant funds be spent at a public laboratory. And we just a few weeks ago started a new contract with one founder who has an SBIR grant, and they're using our resources to test and measure their technology. In that case, the steering of the ship is reversed. So the founder is stating what their research goals are, and we're providing the expertise and the sort of the person power to make those measurements work. There are other grant programs that are specifically focused on ventures and startups and new technology. The Irrigation Innovation Consortium has grants available for startups. There are, of course, constraints. In particular, the IIC is focused on new technologies that will benefit the whole industry. They call it the white space concept. It's basically, if this new technology or research product goes forward, you have to be able to demonstrate that the benefit of that new thing will not be limited to just one small slice of the industry or just that one company. There's got to be broader benefits to the whole industry. The CEC has funding for new technology and energy savings technologies. The commodity boards will have research programs that they're more applied research focused, but sometimes product testing can fit into that. And then what is probably the most common is when the founder already has some investors who've provided funds and want some third-party validation. So that's sort of the straightforward third-party test where all of the funds come from the venture itself. So there's a couple different scenarios, one where CIT leads a research proposal, one where the founder is leading a research proposal and we're subcontract, or one which is just straightforward third-party fee-for-service testing.
Excellent. So I want to get to this question here, and I'll answer a few more that have been chatted in. When it comes to, let's say a founder's watching this right now and they say, this is great. I don't necessarily know where to start. I think I might work for testing, maybe product development, who knows. What's the best way to get in contact with CIT and start that conversation? What do you typically expect, Charles?
Well, most of our contacts either come through email or phone. So if you go to our website, there's contact info at the bottom of the page. You can reach out to me directly at my email, and I think you can find that on our website. Basically, what we will do is try to set up a meeting. Over the past year, it's all been Zoom meetings, but normally we'd like to sit down and talk. We'll take a tour of the lab. And then we basically have a discussion about what is it they want to measure. That discussion will then lead to an initial quote, if it's a special test. So we'll put together a preliminary quote based on what we think the founder needs to do to achieve their product development goals or their testing goals. That's usually followed by a period of negotiation where we reduce or expand the scope based on the budget. And once everybody's on the same page about what we're going to test, then we'll have an agreement document that gets sent through the Office of Sponsored Programs here, and we'll get to work.
For the founders that are, maybe they have investor funds or they're considering other grants, is it worthwhile to reach out to you in advance, or is it better to wait until those are all secured? What's the order that you think is the best there?
Either way is fine. I mean, if you just want to have a preliminary meeting to get a sense of what we think your testing needs are, so that you can go back to your investors and tell them, we talked to CIT and they think we're going to need this many dollars to test our product. We can have that conversation. Generally, it's the more involved special test will actually require, sort of in our minds, developing a preliminary test protocol, particularly if it's a very, very new kind of technology that's, nobody's ever seen this before. Sure. There's actually quite a bit of work involved in putting together a quote, because we've got to figure out what are we actually going to need budget-wise to execute on that test. So for those larger, more involved quotes, we tend to be a little bit more careful because it's a significant amount of work for us. But the informal conversations, we have those all the time. We're always happy to talk to new investors or new founders about their technology and just sort of doing things on the whiteboard. What do we need to measure that? What do we need to measure this? So if you want to have a conversation before going to your investors, that's fine. If you want to have a conversation after going to your investors, that's also fine. That's when we can get down to brass tacks about, okay, if you want to measure yield, you're going to need this many plots, you're going to need this many acres. This is the equipment that we're going to need to get to do that.
Excellent. So I'm going to read a few of the questions here. Charles, are you familiar? I know this is a little, potentially, I'm not sure, but maybe a little outside. Are you familiar if there's any irrigation related master's degree program? And I don't know if this is referring to Fresno State offering or just in general, but.
So Fresno State does have a master's degree program. And we routinely work with grad students in that program for their research projects. In fact, the video that you saw, several of the younger people in that video were actually grad students here at Fresno State. I don't know that the master's program is labeled as irrigation specific, but almost all of the students that are working on their research here are doing something irrigation related. And Fresno State does have a reputation for doing irrigation related research, particularly with master's students. Fresno State does not have a PhD program, so that sort of puts a limitation on the scale of the research products or research projects that we can do. You tend to think of a PhD research project as something that's 4 years or more, whereas a master's research project is 2 years or less. That's never really been an issue for us because we're focused on applied research, and so typically that can happen in the 2-year time frame. But the larger, fundamental science questions tend to be a PhD program.
Excellent. Another question here. Are you doing any research on water treatment and the growing of cannabis?
No, unfortunately, we are not. And I'm only speaking for myself here. I'm a little bit disappointed that we're not, but there are some legal constraints about us doing things with cannabis and hemp that we just haven't been able to overcome those legal constraints yet. We all know in the research community that that's an important cash crop, that we want to be studying it, but until those legal and procedural constraints are lifted, we just can't do it.
Makes sense to me.
Now, one thing I would add is that we can't do cannabis on campus, but if there's a technology that's specific to cannabis production and we can test it without having any cannabis here, that's okay. We've actually had, I won't go into details, but we had one particular testing client who was doing a special test related to cannabis production, right? So there was no cannabis on campus, nothing related to cannabis. The only thing we were basically testing was a very specialized irrigation system, which that's what we do.
Of course. Speaking on that, Charles, this may be a little difficult here, so let me know if this is a no can do, but are you able to give us, without naming names or anything, can you give us some examples of founders that have come through and what they've benefited from working from CIT? It'd be nice to end today with some quote unquote success stories, I guess you could say.
Yeah, so there's one that we have one success story that we've been publicizing fairly well. This is a company called Nitricity. They came up through the Wet Center as part of the Valley Ventures Accelerator program. And they have a technology that makes nitrogen-based fertilizer using air, water, and solar power, right? So there's no natural gas involved. It's made right on site. It's really a fascinating idea. We were able to get a small grant to work with them, and they did some their first field trials here at CIT. They learned a lot. These are 4 PhD students from Stanford. So they didn't really have much agriculture background. And so they were able to experience all those practical constraints and practical headaches that happen in testing in a real agricultural production context. They've done 2 crops here. They just started their 3rd crop. We're doing processing tomatoes again with them here. They were making modifications and doing product development right here on site at Fresno State. They've since gone on to have another sort of pilot project with a fairly large grower here in the Valley. They've gotten a significant amount of venture funding. So the field trials and field testing that they did here really helped them refine their product, understand the agricultural market needs, and how to make their technology fit into a product that works in ag production. And my understanding is that part of their association is what helped them achieve some of their venture funding.
Excellent. Well, I know we're getting towards the end here. Is there any final comments, Charles, or anything you'd like the audience to know that we didn't cover today?
No, I think you've asked me all the questions. One thing I would like to add in the chat window, if I can get Chrome to cooperate with me. Come on, Chrome, help me out here. If anybody would like to know more about the history of CIT, I'm putting a link in the chat window. Part of our association with the Irrigation Association involves a publication that they have called Irrigation Today, which is a grower-focused quarterly magazine that looks at all aspects of irrigation, from technology and policy and industry relations. We had our 40th anniversary last year. And while we would have liked to have a big party here, COVID happened. So we postponed that for this year. We have an annual educational event called Ag Tech Day, and we will be celebrating our 40th anniversary this year. But this publication that I just put into the chat window is a timeline of our history. So you can see a little bit about when we started, our previous directors. I think some of the photos that you saw in the video show up in that as well. So if you want to know where we're coming from and where we've been and where we're going, please take a look at that.
Excellent. Charles, I want to thank you for joining us today. I want to thank the audience for also attending as well. Charles, let me check. Okay, yeah, we do have that. We have the CIT website in chat, so if you want to visit that further, feel free to do that. I'm certain that if you Google Center for Irrigation Technology,
We come up first in Google.
okay, perfect. So at the very least, just remember that. And we'll end there. So thank you all, and we'll see you next month for next month's webinar.
Thank you.